determine the force in each supporting cable. So the first step we need to do is to draw the free body diagram, right? But I wanted to show what. Okay, let's just draw it. Our free body diagram is going to be like this. Let's go to the shapes. Let's put it here. Let's put it here. Okay, let's put it here. Okay, we have this force. We have I think we have 4. It's not 4. It's 3 forces here. Okay. Yeah, you have 3 forces. Okay. We need to right. Yes. I think it's agreeing. Yeah. Let's go. We are left with one force. Okay. It's not a train smash. It's not a train smash. I want to move this force here. Fine. I think we're okay. This is our forces. We're gonna name them. This one is what? This one is AD. This one is AC. This one is going to be let's say BA or AB, whatever you call it, whichever way you want it. And we're gonna have what? We're gonna have forces of component. We know here. We're gonna have forces of component. We know here. Let me show it. Okay. We know below. We know below the we know here it we have okay. I think it's fine like this. I think it's fine like this. We know here here is 30. It's 30 here. Here is theta. Here is theta. Here is 30 degrees. Let me rub it here. Yeah. Here is 30. Okay. Let me just say like this. Here is 30. It's 30 degrees. This is 30, guys. It's 30 degrees. And this force, this force is, we're gonna call it AB cos. AB cos 30. AB cos 30. This one we're gonna call it. This one we're gonna call it AC open bracket 4 over 5. Yeah. Therefore, these are our components. We also have another component here. There are two components. The first one is here, the second one is here. They are both called, this one, the big one is called what? Okay. This one is called what? We're gonna name it AB sine 30. AB sine 30. This one we're gonna name it AC open bracket 3 over 5. Right. Therefore, let's go to the summation of horizontal forces. The summation of Fx x, which is equals to 0. For the horizontal forces, we have this component called AB cos 30, and we also have this one which is AC open bracket 4 over 5. Therefore, it's going to be, we take our direction right as positive. Therefore, we're gonna start with 4 over 5 AC minus AB cos 30. Therefore, we know we want they are both equals to 0. Both equals to 0. Therefore, where are we off to? We want to make, therefore we're gonna make AC our subject of the formula, which is going to be AC 5 over 4 AB cos 30. AB cos 30. Right? We're gonna go to the summation of what? We're gonna go to the summation of the y forces, which is the vertical forces. The summation of the y forces, which are the vertical forces, we're gonna write them as summation of Fy, which is equal to 0. We take up as positive. Let's show it up as positive. Direction. This is direction. We know when we deal a force is a vector. So a vector, it must have a vector. It must have a magnitude and a direction. So we take up as positive. Therefore, where are we off to? Oh, we need to add. Let's look at our Let's look at our forces. We have two forces. The first one here it's AB. The first upward force is AB sine 30. The second one it's AC 3 over 5. Right? Okay. Therefore, we need to another force, it's AD, but this AD we haven't done anything to it. Am I correct? This AD, did they give us AD? Yes, they gave us AD. They said the crate has a weight of 550 Newton, so it means we have AD. Therefore, the summation of the forces is going to be we take upward as positive, right? Therefore, it's going to be 3 over 5 AC AC plus AB sine 30 minus, we need to minus 550 minus 550 I think this 550 is not quite nicely done. Minus, let me write it nicely, 550 is equals to 0, right? Fine. Therefore, we gonna, what do we have? What did we calculate before? We made AC the substitute formula, ne? Okay, so our AC, okay, this we can call it equation 1 if I'm correct, because of this is not, this we can call it equation 1. Therefore, where are we off to? Okay, therefore therefore we gonna substitute equation 1 into 2. Yes, because of we did we're gonna substitute AC into this equation. Therefore, we're gonna let's say substitute equation 1 into 2. Yeah, but we need to show this is equation 2. Fine. Okay. We made AC substitute formula on the horizontal forces. Therefore, here we also have another variable of AC. We can substitute it by mathematics, we know. Therefore, it's going to be 3/5 open bracket. Our AC here is what? Our AC here is 5/4 maybe cos 30 gonna move cos 30 close bracket cos 30 plus AB, right? Okay, plus AB sine 30 minus sine 30 minus 550 minus 550. Are we still together? Therefore, our AB, we're gonna make our AB here substitute the formula, because of we have like terms. We have AB and AB here. The only difference is trig ratios, but we know we can punch on the calculator. Let's punch on the calculator, and we're gonna punch on calculator. These are like terms, and we know when we add like terms can be added. We're gonna add this like term, and that negative 550 we're gonna transpose it. Therefore, we're gonna have our AB it's going to be, it's going to, when you punch the calculator all together and transpose that 550, you're going to have AB 4 plus 3 root 3 over 6 is equals to 550. This 550 is that one. Is that 550 that we got there? That it was negative, not that we calculated it. Therefore, we're gonna divide both sides by this number. We added these two. The 5 over 4 AB cos theta plus AB sine 30. We added it and it gave us 4 plus 3 root 50 is that one. Is that 550 that we got there? That it was negative, not that we calculated it. Therefore, we're gonna divide both sides by this number. We added these two. The 5 over 4 AB cos theta plus AB sine 30. We added it and it gave us 4 plus 3 root 3 all over 6. Therefore, we want to make AB substitute the formula. Therefore, we're going to divide all over by 4 plus 3 root 3 all over 6. Let's go this side. Same applies. What you do on your left hand side, you do it on the right hand side. When you buy, when you are married, if you buy something for your mother, you have to buy something for your mother-in-law also. So you must be fair in life. Okay. Over 3. Therefore, we're gonna get, when you punch here all over, when you punch, let's go and punch. This one will cancel this one. Our AB is going to be, let's go, let's punch it out. I got my ABS 478,46. This is what? This is a force. So it has units. 46 Newton. I thank you. I hope you understood the question, and I hope everyone is happy. Thank you. Oh, no, guys. We are not done. We are not done. We did find AC, but we didn't find... No, we did find AB, but we didn't find AC. We have... this is B8, this one. This is AC, this is AD. So we need... we already have AD, which is 550. So we need to find AC also. We did find AB, which is very good. Let's find AC. For AC, we're gonna substitute. For AC, we're gonna substitute AB into. Gonna substitute AB into 4 over 5 AC minus AB cos 8 equals to 0. Therefore, where were we? Therefore, our we're gonna have 4 over 5 AC. We substitute here on AB. We substituted here, so we're gonna have minus 478,46 cos 30 we know it's equals to 0. Therefore, we're gonna this 400 and negative 446,46 cos 30. We're gonna transpose it to the other side because we want to make AC subject to the formula. Therefore, we're gonna multiply by 5 over 4 in order to have AC as our subject of the formula. Therefore, we're gonna say 5 over 4 multiply by 4 over 5 AC. Therefore, we transpose this number, which is 478, 46 multiply it by 5 over 4. No, we did a mistake here. There's a mistake. We don't. No, we did it. Yeah, we did a mistake. We need to cos 30 multiply. No, this is not nice. We need to write nice. I'm very sorry for my handwriting, by the way. Cos 30 multiply by 5 over 4. Even when I'm teaching on not online, physically straight, people are complaining about my handwriting, but I will try to improve it. Because every day is a learning day. That's why life never stops teaching. Therefore, we're gonna have our ACS. We punch calculator. Let me punch a calculator. Cos 30 multiplied by 4. We're gonna have our ACS 517.95 Newton. If okay, let's draw the force of polygon. Let's draw the force of polygon. I see force a polygon. Force a polygon. Let's draw it. Force polygon. It must gonna have this force. No, let me use those shapes. I think using the shapes really helps a lot. Let me try. Let me try to rotate. Not winning. Let me draw with freehand. Let me draw it with these lines. Okay. Let me rub this thing. We need another one. Uh, no. This one's they're gonna trouble us. They're gonna give us big problems. This one's they're gonna give us big problem. Let me just draw it. Gonna have this one like this and this one like this. Then we're gonna have another one like this one. Gonna have another one like this. This is going to be our angle, which is 36,87. This is going here. Gonna have angle 30. Yeah, this is the y-axis. This is the x-axis. This is force of AC. This is AB. This is your W. You can say it W. Yeah. Good day again, guys. We are doing part 2. We are solving the questions of equilibrium. This problem says the beam has a weight of 3.5 kilo Newton. Determine the shortest cable ABC that can be used to lift it in the maximum force the cable can sustain. If the maximum force the cable can sustain is 7.5 kilonewton. Okay, let me just show my face. This is me. Let's go back to the question. Let's go. Well, the first step is to do what? The first step is to draw. The first step is to draw the first step is to draw the first step is to draw what? Is to draw the first step is to draw the free body diagram. Sorry, a little bit tired. Okay. Let's put this is going to be the force of BC. This thing is starting to trouble me now. Okay. We want to draw the 3.5 kilonewton, which is the upward force. Okay, I think like this is going to be fine. I think it's okay like this. Gonna draw another one, which is the force of AB. Yeah, right now we are okay. Therefore, we're gonna name them. This is the tension force of BC. This is 3.5 kilonewton. This is AB. This is TAB. And we're gonna have what? We're gonna have the component forces. We're gonna put them here. Yeah, I think it's okay like this. And I have the component forces. Yeah, I'm gonna name this one T cos theta. Which theta? Theta is going. It's here. Theta. Even here is theta. Because of symmetry, TBA, the tension on AB and the tension on BC, they are equal, which is equals to T. Therefore, here is theta, here is theta, and here it's also T cos theta. And I think that is that. I think we are fine. So let's go to analytical solutions. The summation of horizontal forces is equal to 0. Direction, we are talking about horizontal. Horizontal has to go that direction. That direction, we take it as positive, right? Which is the right. And we're gonna have T cos theta minus T cos theta is equal to 0. 0 equals to 0. Let me draw the 0 nicely. It's equals to 0. Okay. Therefore, this minus this, these are the same variables. It means we're gonna have 0 is equals to 0. Fine. Therefore, let's go to the summation of the vertical forces, which is equal to 0. This is y, guys. Let me fix it. This is y. I hope you can see it. This is y. Yeah. Horizontal forces is equal to 0. And we take up as positive. Let me draw it nicely. Up as positive. We're gonna have that 3,5 minus I think we are shorting. Here we have two forces. It means we must have what? We must have our components for y. We did not draw them. We need to add our components of y. Yes. This is going to be our components for y, right? We need to add our components for y. We have another one that is here, and we're gonna say we have two forces. It means we need to have how many components? 2 components. We have one component which is called T sine theta, and this one, it is also T sine theta also. Okay, fine. That is that. We're gonna go. So we are going to, it's 3,5 for the vertical summation is 3,5 minus T minus T sine theta minus T sine theta. No, we know it equals to 0. Therefore, we're gonna have negative 2T sine theta is equals to negative 3,5. We transpose that one. We add this one because they are the same variable. Therefore, we're gonna divide both sides we're gonna divide both sides. This is negative 3,5. We're gonna divide both sides by negative. Here you are looking for theta. We're gonna divide both sides by by negative 2. Yeah, we're gonna divide both sides by negative 2. It is going to give us how much? No, we do have t. Our t, but t is equals to 7,5. So we must substitute t. We're gonna substitute this t there. We're gonna have positive 2 times negative 7,5 sine theta is equals to 3,5. Therefore, we're gonna our theta. This is going to 2 times 7,5. It's how much? It's 15. Therefore, we're gonna have sine theta is equals to 3,5 because we're gonna divide that 15 here. Therefore, our theta is going to be sine of inverse of 3,5 over 15. Our theta is going to be how much? Let's take the calculator and check our let's take our calculator. Sine of inverse 3,5 over 18. Therefore, we're gonna have our theta as 13,49 degrees. I think we are done, but we are not done. Are we done? We are not done. We are done with theta, but we did not find the force of BA. But we do understand that. We do understand. Therefore, cos theta is equals to DC over BC, which is, let's go to the diagram. Let's go to the diagram. I want to show you something. This is AB. This is AB. This is BC. Wait, DC. Where is DC? And therefore, okay. Therefore, where did we find this thing? This thing, we found it like this. Let's go to the diagram. Our diagram is like this. It's ABC. So it's going to be, it's AB. It's cos theta is equals to A B C BC is equals to AC. This is AC. So it's not D. We do not have D. Therefore, we're gonna fix this one, which is going to be AC. AC. Where did we find this? We drew. We're gonna draw a triangle like this. And this is going to be our B, but it has to be like a nice B. This is going to be our B, going to be our C. This is going to be our A. This is going to be our theta. This is going to be our theta. This is 1,5, right? Okay. Yeah, I think we are winning. Therefore, we know that BC is equals to BA equals to no, this is DC. This is also D. This is DC, which is equal to DC over cos theta. Therefore, we're gonna have our BC is equals to BA, which is 1,54. Our ABC is going to be 2 times 1,54, which is going to for our ABC is equals to 3,09 meters. Let me draw this meters nicely. Meters. Yeah, that is that, guys. We are done with this problem. I hope you understand, and I thank you. Good day. We're gonna continue with doing the equilibrium questions. Let's go to the problem 3. The problem 3, it says that if the 5 kg block is suspended from the pulley B and the sag of the cord is D is equals to 0,15 meters, which is parallel to the y-axis, as we can see it, and determine the force in ABC. So the first step that we need to do is to draw our free body diagram. It cannot sit like this. This one we have to name it. Okay, this is the force of BC. Let's go and look for another force. Sorry. This is let me. Yeah. This is nice. This is tension force AB. This is tension force BC. Let's go look for another tension force. This is weight. Weight has to oppose this is going to be weight. No, man, I want to. Yeah. This is going to be weight. Let's name our forces, guys. Naming our forces, we're gonna say this one is weight. We're gonna say this one is T, B, C. This one is T, A, B. Yeah, it's gonna be T, A, B. This one. Therefore, this is our free body diagram. But to make your work very easily, we have to draw what? We need to draw the forces of component. But before we draw the forces of component, here the only information they give us is we have what? We have the sec of the chord, which is 0,15, and it is shown below that from A to C is 0,4. So we can literally say here is 0,2. So if we can draw a triangle like this, this is going to be 0,15. This is going to be 0,2. So we're going to use the theorem of Pythagoras. These are all in meters. We're going to use the theorem of Pythagoras to find the another side. As we know, when you have two variables and one unknown variables in a triangle, you can use the theorem of Pythagoras to get another one. So on this case, we can say, we're going to say our R, we're going to say our, we're gonna say R is equals to R is equals to is this 0,2 squared plus the opposite side, which is 0,15 squared. Therefore, let's punch the calculator. 0,2 squared plus 0,15. Therefore, we get our R as 0,25. It's in meters. We got our R as 0,25 meters, right? Therefore, we can now show our I want us to show to show what no, this is too long. I want us to do yes. This is going to be our forces of components. Okay? Right. Therefore, we're gonna have we said our R is what? Our R is 0,25, right? We said our R is 0,25. This is our R, the hypotenuse side. Therefore, it means here this is the component of. We need another component. Okay, this is the component of T. Okay, we're gonna need another component. This you can see. I need another component. think it's fine like this. Therefore, we can name our component. This here we have TB, so it's going to be T B C is equals to is equals to is equals to 0,2 over 0,25. Let me draw it nicely. Zero comma 2 over 0,25 or 0,25, but we know, sorry, and here we're gonna have a force. Here we're gonna have a force of T open bracket 0,2 over 0,25. Sorry, 0,25. But we have two forces here. Both forces is going to be T open bracket 0,15 over 0,25. Even this one is going to be T open bracket 0,15 over 0,25. Okay, this is our upward forces. Therefore, we're gonna go to our analytical solution. Well, the only thing that we left is W is equals to mg. We know W is equals to mg is mass plus gravitational acceleration. Where we have our mass as 5 here. It's going to be 5 multiplied by 9,81, which is going to give us 49,05 Newton. That's our first step. Therefore, this is our first step, right? Therefore, we're gonna look. We do not have angles, so let's say this is okay. We do not have angles, so we're gonna have theta here and theta here. So we're gonna calculate the angle theta now. You're gonna have tan theta is equals to, we know it's opposite over adjacent, so our opposite, let's look at it, 0,5. So it's going to be 0,15 over 0,2. This is our adjacent, which is parallel to which is parallel to the horizon. Therefore, we're gonna transpose. Our theta is going to be tan inverse of 0,15 over 0,2 over 0,2. We're gonna punch on calculator and get our theta. And let's punch on calculator. Tan of inverse open bracket 0,15 over 0,2. Therefore, we got our theta is 36,87 degrees. That is that. We are not done. We haven't. We are not done. We haven't. We did not do the summation of of the summation of the forces. So for the horizontal forces, we can see the horizontal force. We can see it's let's zoom it. The horizontal force is this force. Let me highlight it. This is this force and this force. Horizontal is this force and this force. Therefore, we're gonna see they're gonna subtract it because of one has to take another direction, which is positive. Another one has to take another direction, which is negative. So, on this case, they said if the 5 kg block is suspended from the pulley B and the sag of the cord is D is equals to 0.15 meters, determine the forces on ABC. Neglect the size of the pool. Okay, let's start with the summation. The summation of what? The summation of the y. Summation of the y. Gonna say summation. No. Summation of vertical forces is equals to 0. Summation of vertical forces is equals to 0. Summation of vertical forces is equals to 0. Take the up direction is positive. Take the up as positive. This is direction. Therefore, we're gonna have what? We're gonna have. Let's look at our diagram. We have 2 T that are going up. Ne? Means we're gonna have 0.15 over 0.25 T plus 0.15 over 0.25 T. We're gonna minus it by W. Minus. Did we find? Yeah, we did find our W. Minus by W is minus by 49.05. No, we know it's equals to 0. All over is equals to 0. Okay, let's write it. Let's not. It's equals to 0. Therefore, here we have same variable, which is T, both T's. We're gonna add them. We're gonna have 1.2 T is equals to that 49. We're gonna transpose it, which is going to be positive 49 0.5. Therefore, we need to remove this 1.2. We divide by 1.2, divide by 1.2. We find our TS 40.88. When we punch a calculator, when we punch a calculator, we're going to find our TS 40.88 Newton. Therefore, we are not done. If you are being told to find the force of polygon, we're going to need to draw the force of polygon. The forces of polygon. This one is going to be a little bit tricky, but it's not a train smash, guys. It's not the train smash. We're going to draw the forces of polygon. I have this as our W. Therefore, we're gonna, this is going to be the T. We need the TAB. That is the TABC. We're gonna need the TAB. We're gonna need the TABC. Okay. It's much better if I start with this one. Okay. Just hope everyone understand. Just please. So this is not going to be long. Yeah. I think everyone understand now. Therefore, we're gonna name this is force polygon. This is we're gonna name this is W. This is T A B. This is T B C. This is B. This is TBC. This is our y-axis. This angle, we're gonna name it at 36,87. This angle. 36,87. And this is what this is our x-axis. This is our x-axis. So guys, that is that. I think we already answered the question. Did we? Yeah, I think we already we answered the questions. I think everyone is satisfied, and I thank you guys. Thank you. Good day. We are continuing with the questions of equilibrium. So on this question, they say that if the mass of the cylinder, I hope it is visible enough. I say that if the mass of the cylinder C is 40 kg, determine the mass of the cylinder A in order to hold the assembly in positions shown. So in this case, what are we going to do? We are looking for the mass. We have the mass of the cylinder C. We are looking for the mass of the cylinder B. So in order to see my face is here I am. We're going to look into this question right now. So the first thing that we need to do is to draw the free body diagram, right? We have a force that is going like this. We have to draw a free body diagram for body A and body B. So we have a force that is going like that, which is tension EB. And please look at something. At the body B, there is no friction, which is body C. At body C, there is no friction. So tension at EB and tension at BC is going to be the same. Okay. Right now, let's just draw the free body diagram first, so that we can attack. We only have mass. Let's just draw the free body diagram first. This is the tension of EA, and gonna draw the tension of ED. It's going to look like this. Little bit upward. Okay, I think it's fine like this. Right now we can name our forces. Here we have TEB. Here we have TEA. And here we have TED. Okay. And okay, this is for body A. For body A. But what I like to do mostly, in order to answer these questions, you need to do what? You need to show the vertical and the horizontal component. So this dotted line or the imaginary lines are going to represent what? Are going to represent the what? Are going to represent the component of the forces, right? Okay. Therefore, here we have a vertical component, and we need to show a horizontal component also, which is going to be like this. Yeah. Fine. Here, this vertical component, we can name it. We should name it. We will name it. We will name it what? TEB sine 30. This horizontal component, we're gonna name it TEB cos 30. Therefore, I think we are done with our diagram. We can go. This is the diagram for body A. And we also know at pulley B, at pulley B, there is no friction. Therefore, okay, let's go to the questions straight right away. We at pulley B, there is no friction. Therefore, TEB is equals to TBC. How do we get TBC? TBC we know who is going to be TBC is going to be WC is equals to mg, right? Therefore, we have the mass, which is 40, is going to be 40 multiplied by 9,81, which is going to give us, take the calculator, 40 multiplied by 9,81. It is giving us 392 Newton. Fine, that is that. And we also have the angle here, which is 30, right? This angle is 30. We're gonna go to the summation of the vertical forces, right? We're gonna go to the summation of the vertical forces. We know the summation of vertical forces is equals to 0. We take up what? That's the positive direction. Fine. Therefore, we have what? We have TEB sine 30 minus this force. Let me highlight it. This force. Because of we took the upward direction as positive, this force is going to be negative. Negative what? Negative TEA. The T, it represents the tension, is equal to 0. We only have two forces here. Therefore, we're gonna call this equation 1. Fine, that is that. And we also said TBC is equal to TEB because of there is no friction. Therefore, we calculated the TBC. It means we calculated TBC. We did calculate BC, the tension on BC, which is 390, we're gonna say, but TEB is equals to TBC is equals to 392 Newton. Okay. Therefore, we can substitute TEB into equation 1. We're gonna substitute this TEB, which is 392 Newton. Therefore, we're gonna have our equation 1 is TEB sine 30. Therefore, it's gonna say we're gonna have what? We're gonna have 392. This 3 does not want to look nice, man. 392 sine 30. Let's transpose this TEA, this side. TEA. Therefore, our TEA is going to be, let's punch the calculator. Our TEA is going to give us 196.2 Newton. Okay, but we are not done. We know tension of EA is equal to mg. The mass of A is equal to TEA over G, which is going to be 19.62. It is 196, not 19.62. 196.2 over 9.8. Therefore, we're gonna get let's calculate 196.2 over 9.8. Therefore, our mass of A is 20 kg. If you are given that you should draw the free body diagram for if you are given that you should draw the free body diagram for the body of B. Let's just draw it. First. Let's just draw it. Yeah. If a question arises that you should draw the free body diagram for body C, we're gonna have TBC here. We're gonna have another one TAB like this. TAB is gonna look like this. Fine. But they need to join each other. They need to join each other nicely. I think it's fine like this. Therefore, we're gonna have our imaginary line representing what? Representing the component of the forces, which is going to be like here, which is going to be here. Fine. We're gonna name our forces. This is for body. This is for what? Body B. That one is for body A. This is TBC. This is going to be the T. This one. This is TEB. If you are given to draw it, so that is that. If you are also advised to draw what? To draw the force of polygon. Okay, let's draw the force of polygon, guys. Gonna draw it here. I'm gonna use it my freehand force polygon. Let's draw it. Gonna have one force that is going like this, another one that is going like this, another one that is going like that. Okay, this is TEA. This is T. This is going to be TEB. This is going to be FTD. That is that. Your scale is going to be 1 centimeter, which equals to 100 Newton. That is that, guys. I hope you understood, and everything is clear. If you have another problem, we're gonna do it together. I thank you, guys. Good day. We are continuing with the equations of equilibrium, guys. We are at problem 5 right now. Sorry. Say that determine the tension in cables AB, BC, CD necessary to support the 10 kg and the 15 kg traffic lights at B and C. Respectively, also find the angle theta. Okay. Gonna look for 3 things. Here we're gonna work, guys. Let me just show my face in order. Those who want to recognize me when they see me. Physically when I teach. But those who know, they know. Let's attack this question. The first thing that we have to do is to draw the diagram. The diagrams. The first things. So, let's draw the diagram for point B. We can say we have joint B and joint C. Or point C. Let's draw the diagram for point B. Okay, we're gonna have, this is FAB, if I'm correct. This is going to be FAB. We're gonna have another force that is going downward, which is going to be the weight, right? This thing is troubling me, but it is not a transmesh, right? Aha. It is not a transmesh. to look nicely. I think it's okay in this one. We are left with one force. We are left with one force that is going that side, which is I think it's fine in this manner. I think it's okay in this manner. Let me just I think it's fine. But okay, let's name our forces. This is for body. This is for body. B. Gonna name our forces. Okay. I want to write it. This is for body. Body A. Body B. We do not have body A here. This is for body B. Therefore, where we opt, we need. This is FBC. FBC. This is W. This is FAB. Yeah. This is FAB. We need to show again what? We need to show again our we need to show again our what? Our X, not X, our component for us to be on the on the safe side. I want to move this thing, but it is troubling me. I need to show our component, because of without component we're gonna see ghost. Yeah. Sorry, this is the vertical component, not the vertical, the horizontal. We need to show our vertical component. Our vertical component is going to be like this one. Okay, see, I think it's fine like this. We have we have our component, but we need to name them. This is going to be AB. AB cos. Do we have an angle? Oh, this angle we must name it as 15. AB cos 15. AB cos 15. This horizontal component, we need to name it, not the horizontal, the vertical. AB sine 15 degrees. I think we are done with the diagram for point B. This is the free body diagram for point B with components. Without components, we just gonna draw the forces only. Therefore, the analytical solution, we're gonna start with the weight. We know the weight is much easier to solve, which is going to be W. We know W is equal to mg, right? Our weight is going to be how much? Our weight is going to be, we have 10 here. They give us 10. It's going to multiply by 9,81, which is going to give us 98,1, if I'm not mistaken, because we just multiply by 10. We are going to the summation. We are going right now. We can literally go to the summation of the forces. Therefore, here we have the summation of the vertical, summation of the vertical forces is equal to 0. Let me draw this y nicely. This y does not want to look nice. Why? Why is that? Is that up? Okay. The summation of the y forces f of y is equal to 0. We take up as positive. No, wait. Why is this thing doing like this? We take up as positive. You know, when we deal with forces, when we deal with forces, a force is a vector quantity, and we know vector quantities, they have mass and they have directions. So we take our upward as positive, and we're gonna add our what our forces. The upward, we said this what. Let's look at it. Let's go and look at it. It's AB sine 15. It's AB sine 15. So therefore we're gonna have AB sine 15. AB sine 15. This one, the W, since it's going downward, we're gonna say minus 98.1 is equals to 0. It's equals to 0. Therefore, we can get our AB. Our AB is going to be. We can get our AB. Our AB is going to be. We transpose that one. We transpose that 98.1, and therefore we divide by sine 15, both sides. Therefore, our AB is going to be. Let's take the calculator. 98.1 divided by sine 15. Yeah, this 15, you close it into bracket. Therefore, our AB is 300 and our AB is 300 and our AB is 379.03 Newton. This is a force. It's a force method, and it must have units Newton. We are not done. Still have a lot of work to do. We need to add the. We need to show the summation of what? The summation of horizontal forces. Let's go. Summation of f of x is equal to 0. Take right as positive. We do it. Take right this arrow, right as positive. Fine. Therefore, let's look at our diagram. We have FBC and we have FBC and AB cos 15. Therefore, it's going to be BC minus AB cos 15 is equal to 0. Therefore, we calculated the AB. We can substitute AB here. Therefore, we can say BC is minus 3 minus 379 cos 15 is equals to 0. Let me write this very nicely. It's equals to 0. Therefore, we're gonna say our BC is we transpose this number and punch it. Our BC, we're gonna get it. Let's punch it. 379 cos 15 is equals to 366.11 Newton. I hope we understand it, but we are not done. We need to draw the free body diagram. We need to draw for point C. We are done with point B. Everything is rest assured. Let's go to drawing the free body diagram of point C. Oh, I'm not looking for the background. This thing, it wants to trouble me, but this one is not a transmission. Oh, God. Let me see. Okay. It's not a tense mesh. It's not a tense mesh. We want to draw the free body diagram for point C. Gonna have a force that is going upward like this. Let me see. Yeah. Force that is going upward. The other one is to go to the left. The other one is to go to downward. Okay, it's fine. You're gonna say the other one is to go to the left. Right. Other one is to go. This one has to go to the left. I think it's fine like this, and we have we need to draw the W of C. W of C, yeah. Please do not trouble me. Yeah, this is going to be the W of C. Hope it's clear, everyone can see. We're gonna name these forces. This is, let's say, WC, weight of C. Did we calculate it? No, we haven't calculated it. This is force of CD. This is force of BC. We're gonna go to the vertical and horizontal what? Vertical and horizontal and not asymptote. Yesterday I was teaching mathematics today. The vertical and horizontal what? Vertical and horizontal components. We're gonna go to the vertical and horizontal component. This line. It is troubling me. It does not want to. Right now we are winning. This is going to be our vertical component, and we need what? The horizontal component also. Trouble me? Please don't trouble me. It's troubling me. But it's not a joint smash. It is not a joint smash. Yeah, okay. Let's see. Will it move? Ha. Yes. Ha. Right now we are moving forward. We have our vertical and horizontal component. This one we're gonna call it CD cos theta. Which theta? Here is going to be theta. Okay. Right, nice. This is going to be our theta. Here we're gonna have CD sine theta. think right now we are within. We are within. Therefore, we're gonna calculate the W. We know equals to mg. They get the first one. It was 10. This one it has to be 15. The mass, which is 9 multiplied by 9,81. Our mass is going to give us 177,5. Yeah. Okay. Therefore, where are we off to? We are. This is the body of body C. Body C. Okay. Where are we off to now? Right now we need to go and calculate what? We need to go and calculate the summation of the forces. Therefore, we're gonna say summation of Fy is equals to 0. Direction. Do not forget direction. Upward as positive. Therefore, we have CD sine theta. We did not calculate theta, yes, and they want theta minus this WC. It's what? The WC the WC is 147,15 is equals to 0. Therefore, our CD is sine theta is going to be, we transport this 147,15. We're gonna call this equation. This is going to be equation 1. That is that, guys. And we're gonna go to the summation of what? Of horizontal forces. This is summation of f of x. Yeah, f of x. When we look at them, we f of x is equal to 0. We take right as positive. Therefore, we have only two forces, which is CD cos theta and FB cos theta, right? This is CD cos theta and BC. Therefore, we're gonna have CD cos theta, CD cos theta, minus BC is equals to 0. It's equals to 0. 0, 0, 0. 0 is equals to 0, guys. Therefore, what do we have? On the previous, I think BC, we did calculate it. I remember mentioning it. Here, we do have BC. Let me highlight it. We do have BC. Here. This is here. This is our BC. So we can substitute this BC onto that equation, right? Therefore, we're gonna say CD cos theta is equals to, we transpose this BC. Our CD cos theta is going to be how much? 360 plus 366,11 Newton. We know it's Newton. We're gonna call this equation as equation. This is going to be equation 2. Okay, this is going to be our equation 2. Since we have a big problem here, we have two unknowns, which is CD cos theta and CD sin theta. Oh, I can see it now. We have two unknowns. Therefore, we can equate these two unknowns. How? I'm also asking myself. How? Okay. We have CD sin theta and CD cos theta. Okay. Let's equate them. CD sin theta is equals to 147,15, right? 15. Let's divide it. Let's see, divide it by CD cos theta over 366,11. I'm sorry. Therefore, CD is gonna cancel CD, gonna be left out with a trig ratio called tan. Let's take the calculator and check. No, we want theta. Tan 147,15 over 366,11. Therefore, where are we off to? We have to transpose the tan ratio, not ratio. Is it ratio? Yeah, it's ratio. Theta is going to be tan of inverse of 147,15 over 366,11 close bracket. Therefore, we're gonna punch it on the calculator. Let's punch it on the calculator. Tan inverse 147,15 over 366,11. We get our theta as 21,90 degrees. We are not done. We did find theta. We did find BC, but we did not find. Let's look. Let's look at the question. We did find AB. Where's AB? Yeah, AB. We did find it. We did find BC, but we did not find CD. We can literally take one equation and substitute it to find CD. Okay, let's use equation 2 to find. Let's use equation 2 to find CD. Where is equation 2? Equation 2. This is equation 1. This is equation 2. Equation 2 says, okay, I see it. We're gonna say it's clear. Equation 2, we're gonna say CD no, we said equation 2, not equation 1. CD, even equation 1 is gonna give us the same answer, cos theta is equals to 366,11. Therefore, we divide by cos theta. Our CD is going to give us, so the 444. 366,11 over cos our theta is how much? Is 21,9. Gonna punch it on the calculator. CD 366,11 cos 21 cos 21,9 bracket. Our CD is 394,8 Newton. We are not done. Are we done? We are not done. I think we are not done. We are left with drawing we are left with drawing the force of polygon for both we are left with drawing the force of polygon for both equations. Let's start here. We're going to draw the force of polygon for both equations. Force polygon. Now let me just draw it with the hand. Have this force, which is going to be WB. This is the y axis. No, let me rub this thing. It's not nice. It's not beautiful. It has to be nice and beautiful, guys. Go ahead. These are the x-axis. These are the axes. One force has to go like this. Another one has to go like that. This one has to go like this. This is going to be our 15. This is our WB. This is going to be our force of BC. And this is going to be force of AB. This is x-axis. If they wanted, this is going to be your y-axis. That is that, guys. I think. Oh, this is for paint. This is force polygon on for B. This is for B. Let's go draw the force polygon for C. Let me see polygon for C. This is the x-axis. You're gonna have a force that is going like that. This one that is going like this, and this one is going like that. This is CD. This is BC. This is going to be WC. This is the y-axis. This is the x-axis. Gonna have angle theta here. That we calculated. Yeah, that is that, guys. I think everyone understood, and I thank you.